Vectors 2 is about components. Okay, consider this. A hiker walks for 8 kilometers in the direction shown. How far east of their starting point will they be? So what we're effectively doing is we're starting with the resultant, and what we want to know is how far east have they gone, how far north have they gone, and what we're talking about are the components of this vector. It has a component in the east direction and it has a component in the north direction. And on this diagram, what I've done is I've resolved this displacement vector into two perpendicular components. I've split it up into components at right angles to each other, such that if we were to add the components together again, we would end up with what we started with. So resolving means splitting a vector up into components, into two components at right angles to each other. Here I'm talking about a force. It would work with any vector, but I'm talking about a force here, and we have an x and a y direction, and the x and y components are fx and fy. And then very simple to prove with a basic trigonometry, fx equals f cos theta and fy equals f sine theta. If the angle theta is kind of tucked in between the resultant and the component, then it's cos. If it isn't, then it's sine. Okay, here's a couple of examples. A tractor pulls a log with a rope. If the tension in the rope is 5 kilonewtons, what's the horizontal pulling force acting on the log? In other words, what's the horizontal component of that force? The next question is a little bit trickier. A block of mass 2 kilograms rests on a slope which is 35 degrees to the horizontal. What is the component of its weight down the slope? The answers are, okay, first one straightforward is just 5 cos 20, which is 4.7 kilonewtons. On the second one, what I've done is I'm resolving down the slope and into the slope. You don't have to resolve horizontally, vertically, as long as the two components are at right angles to each other. And here, if I resolve down the slope, then the component of its weight down the slope is mg sine 35, which is 11.2 newtons. The component of its weight into the slope will be mg cos 35. That will actually be equal to the normal contact force from the slope. Equilibrium of forces. We'll talk a lot more about forces later, but while we're on vectors, if an object is stationary, then there's no resultant force acting on it, so all the forces must cancel. So using this idea of resolving, if we resolve horizontally, then we know that there's no resultant force, so F equals T sine theta. If we resolve vertically, again, there's no resultant force, so mg will equal T cos theta. And if you're good at maths, you might have spotted that F divided by mg would equal tan theta. If the mass of the ball was 200 grams and the angle shown was 20 degrees, calculate T and F. I'll leave that to you. The answers are in a couple of seconds. There. Here's a little bit of a trickier one. A 3 kilogram mass is suspended by 2 wires as shown. Calculate the tension in each wire. Okay, now there's two ways of doing this. One way of doing it is by resolving vertically and horizontally, and if you do that, you end up with two simultaneous equations, and you can solve them and you get T1 and T2 that way. There is a simpler way of doing it, and that is if we resolve in the direction of T2, then we don't have to worry about T1, and if we resolve in the direction of T1, then we don't have to worry about T2 because they're at right angles to each other. and we get the same answer but a lot quicker. A bit more practice, calculate the x and y components of the vectors below, and I'll show you the answers in about 2 or 3 seconds, and the answers are that. Adding vectors together. Now, if they're in the same direction or in opposite directions, it's easier. If they're at right angles to each other, then we can use Pythagoras. What if they're not at right angles to each other? Well, there's 2 ways of doing it. One way is to do a scale drawing. Okay, if you do a scale drawing and put one vector after the other vector, and then the resultant is the vector that would have the same effect as those 2. And so you do your scale drawing, and whatever your scale is, you measure the magnitude, you measure the angle, and that's your answer. The second way of doing it is to resolve each vector into its x and y components, add together all of these components in the x direction and in the y direction. That should total x and y components, that should say, and then use Pythagoras and trig as before. Which method do you think would be more accurate? And it's obviously going to be the mathematical way. Depends how many sig figs you use. Which do you think you might be asked to do in an exam? And again, it'll be the mathematical way, because when you get used to it, it'll be a lot quicker.